Assalamu alaikum and hi everyone, how are you guys? Today we are going to start lesson number 11 on decimals, in which we will be covering these three concepts from 11 till 13. And thank you very much guys for watching and learning here. You guys are amazing and you're the best audience. So let's begin our today's session. So what are the like and unlike decimals? Decimals with the same number of decimal places are called like decimals, which means same number of decimal places. So it means we are talking about the numbers or the values that comes after the decimal point, right? For example, 33.123 and 5.776. so if you see, the numbers before the decimal points are having different values, different number of quantities. In this we have two numbers, in the second number we are having one value, which is 5. So our concern is on the numbers that comes after the decimal point, right? So they should be same in order to pronounce or call them as the like decimals, so each having 3 decimal places. Okay, and what are the unlike decimals? Decimals with the different number of decimal places. So when we are having the same number of decimal places, we named it as a like decimals, and when we are having different number of decimal places, we name them as unlike decimals. So here is an example: 3.4, 5.808, 7.22. so all these numbers are having different number of place values, so they are going to be called as unlike decimals, right? Okay, now here is a note: we can convert unlike decimals into like decimals, right? So can we convert a like decimal into unlike decimals? No. So we can only convert unlike decimals into like decimals. How? By placing the zeros on the right side of the decimal point. So here is an example. For example, these are the two numbers, 4.343 and 2.7. so both of these two numbers are unlike decimals, right? So these two numbers are unlike decimals. So how can we make these two numbers as like decimals? So here we can see the maximum number of digits in this number are 3 digits, 343. So we can, and over here this is 2.7. so how can we make them like decimals? By placing the number of zeros after the decimal point. So here you can see 3 digits in here, 3 digits in here. So now both of these two numbers become like decimals from unlike decimals, right? Okay, moving on to the next concept, which is terminating and non-terminating decimals. So now what are the terminating decimals? Are decimals in which a number of digits after the decimal point is finite. Finite means it has a certain end value, right? It has an end, means we obtain 0 as a remainder, is called a terminating decimals, right? If we keep on dividing those numbers, so we must always get a 0 in our remainder. So we can say that that particular decimal value is a terminating decimal. Or such fractions or rational numbers for which long division terminates or ends, right? It's been written already here. Ends after a finite number of steps can be expressed as a terminating decimals. Anything that ends, that terminates, that has an end, so that is your terminating decimal. So here is an example. Let's solve this example. 7 comes inside the square root sign, 8 goes outside, so it becomes our divisor. So let's start divising. Put 0 here and a decimal point, write 0 here. This number becomes bigger. Now we can divide. Start counting the times table of 8 up till 70 or less than 70, close to 70. So this will give us 8 times 8 is 64. Simply take away these numbers. The remainder we are getting with us here is 6. Now we cannot divide 6 on a times table of 8, so it means I have to put 0. So now I am allowed to put 0. Why? Because I've already put a decimal point here. So now I'm allowed to put as many zeros as I can. So simply by just putting 1 0, my number becomes 60, which is greater than my divisor 8. It means we can divide. Start counting the times table of 8 up till 60 or close to 60. So this will give us 7 times 8 is 56. Simply take away these numbers, then the remainder we are getting here is 4. Now again put this number becomes smaller, we cannot divide, so that's why I'm going to put a 0 here. So now start counting the times table of 8 up till 40. So this will give us 5 times 8 is 40. Take away these numbers, we are getting a remainder 0. So when we are getting a remainder 0, it means that particular fraction or a decimal value is our terminating decimal, right? So the answer we are getting, so this answer is a terminating decimal. So it has an end. This decimal value ends at digit 5. So the answer to this question is 0.875. Similarly, let's solve the next question. 4 comes inside, 25 is my divisor. So since we cannot divide, I'm going to put a 0 with a decimal point. So now I'm allowed to put 0 here. 1 times 25 is 25. Take away these numbers, remainder we are left with this, with s is 15. Since this 15 is smaller, so I have to put 1 0. Now start solving this, start counting the times table of 25 up till 150 or close to it. So this will give us 4 and 6. 6 times 25 is 150. Subtract these numbers, we are getting a remainder 0. So whenever we are getting a remainder 0, the answer the decimal value we're getting in our answer is terminating decimal, right? Okay, moving on to the next category, which is non-terminating decimal. So a decimal in which the number of digits after the decimal point, remember this thing, are infinite, or it has never end, endless values, right? It has no end, it keeps on moving, is called non-terminating decimals. The things that we cannot terminate, that we cannot end, simply those decimal values are called non-terminating decimals. Or when we converting a fraction rational number into a decimal and divisions never ends, such decimals are called non-terminating decimals. Let's see it with an example. So non-terminating decimals further classified as, so there are two further classifications of non-terminating decimals, which are recurring decimals and non-recurring decimals. So recurring decimals, you can simply pronounce them, or you can recall them or memorize it as a repeating decimals. After the decimal point, the values are keep on repeating itself, right? So that's why we name it as a recurring or repeating decimals. So these are the non-terminating or repeating decimals. Since repeating or recurring is a further categorization of non-terminating, so that's why. So these are the non-terminating and repeating decimals in which single digit or block of digits repeat itself an infinite number of times. Why infinite? Because we are talking about non-terminating. After the decimal point are called the recurring decimals. Let's see an example. This is 1/3. Let's solve this question to see whether we are getting this answer or not. So put 0 here, put a decimal point, then we are allowed to put 0 over here. So 3 times 3 will give us 9. Subtract these numbers, we are getting remainder 1. So again put 0 here, then again 3 times 3 is 9. Subtract these numbers, remainder is 1. Since this 1 is smaller than this 3, I cannot divide it, so that's why I'm going to put 0 here. Again 10. 3 times 3 is 9. Take away these numbers, we are getting a remainder 1. So see, it keeps on moving. It is not going to be end anyway. So since in this case we are just going to put these dots, it means the number 3 is keep on repeating or keep on moving. It's never ends, right? So in this case, since this is my non-terminating, right, the number is not there is no end in solving this solution, so this is non-terminating. Now next, what are the values after the decimal point we are getting? So they are repeating, so that's why they are recurring. So it's non-terminating and recurring decimals, right? I hope you have got the concept. Similarly, this is an example. You can solve this question on your own to see whether you're getting this answer. So see, this decimal value is not going to be end. It keeps on moving, so that's why it is non-terminating. And second thing is the values after the decimal points are keep on repeating, so that's why they are called the recurring or repeating decimals. So it's non-terminating, recurring decimals, right? And similar is the case with the third example. The numbers are keep on repeating, so it's non-terminating, and the number is keep on moving, there is no end, so it's non-terminating, plus the numbers are repeating itself with a certain pattern after a regular interval of time, so that's why they are recurring or repeating, right? So second subcategorization of a non-terminating decimal is non-recurring decimals or non-repeating. In this case, the numbers are moving, the numbers are not going to be end, but in this case the values after the decimal points, they are not repeating, only the difference is this. For example, the pi. Okay, let's just read out this one. These are the non-terminating or non-terminating and non-repeating decimals in which the number of digits after the decimal points are infinite and less, but digits or blocks of digits are not repeating itself, right? Simple. So non-recurring decimals cannot be represented as a fraction. We cannot write them in the form of fraction general form p over q, so they are irrational numbers. And remember the definition of irrational numbers, those numbers that cannot be written in the form of p over q, right, which means in the form of fraction. So non-recurring decimals created using a pattern. This is a very big hint or a clue. So never mix this thing with the repeating decimals. In repeating decimals, the numbers are keep on repeating, right? But in this case, the numbers are not repeating itself, but they are making a certain pattern. For example, this is 10. This 10 is not going to repeat itself, but it is making a certain pattern. If you times this 10 with 10, you're getting 100. If you times this 100 with 10, we are getting 1000. Times this 1000 with 10, we are getting 10,000. Or simply, if there is 1 0, then 2 zeros, 3 zeros, 4 zeros. So this is a sequence or a pattern it is making, this particular decimal value, and it is not ending. So this is non-terminating, plus this is making a certain pattern, so this is non-repeating or non-recurring, right? Similar is the case with this example, 1 2 1 1 2 2. So number of digits are increasing, 1 1 1 2 2 2. So 3 times 1 3 times 2, 4 times 1 4 times 2, right? Since the number is not ending, so this is non-terminating, plus they are making a certain pattern, so this is non-repeating. The numbers are not repeating, but they are making a certain pattern, right? So here are few important key points related to these decimals, terminating and non-terminating decimals. So terminating decimals can be represented as a fraction, so it is a rational number, which means we can write it in the form of p over q, or it can be written in the form of a fraction. A non-terminating decimals represent either recurring or non-recurring. So these are the further two types of non-terminating decimals, right? Recurring means repeating and non-recurring means non-repeating. There is no repetition. So recurring decimals are basically the subtype of non-terminating, and plus recurring means it is repeating decimals. And non-terminating decimals or non-recurring decimal is a subtype of non-terminating, and numbers are not repeating, so that's why we are called non-repeating or non-recurring decimal. So non-recurring decimals cannot represent as a fraction. So terminating decimals, we can represent it as a fraction, and non-terminating decimals, in the two categories of non-terminating decimals, the second category, which is non-recurring, it cannot be written in the form of a fraction, right? So these are the things you need to keep in mind. This is a rational number, this is an irrational number. That's it. So let's do a quick overview on these decimals up till now, what we have discussed and studied here. So decimals have been categorized into two parts, terminating decimals and non-terminating decimals. And in terminating decimals, we have learned this thing that these decimals values are rationals, which means we can return them in the form of fraction, plus they terminates, or they have certain end, or we are getting a remainder 0. So these all are the hints or the clues in order to find out whether any particular decimal value is a terminating decimal or not, right? For example, this one 0.08, so it ends over here, so this is terminating decimal. It has a finite values after the decimal point, or we can write it in the form of fraction. Coming to the next second type, which is non-terminating, it can further classified into recurring and non-recurring. Recurring means they are repeating, and non-recurring means they are not repeating. Plus non-terminating means it has no end, which means it keeps on moving, or it has infinite number of values after the decimal point. Whereas non-recurring means also the same thing, because this is also a subcategory of non-terminating, right? Infinite, no ends. And in this case, this is rational. Recurring decimals are rational, which means we can write them in the form of a fraction. And non-recurring decimals or non-repeating decimals, they are irrational, which means we cannot write them in the form of a fraction. Plus the most important thing in this case is they are making certain patterns, right? Okay, moving on to the next concept, which is rules to find whether any given particular rational or fraction value is terminating or non-terminating. How we came to know by looking at it that this is a terminating one or non-terminating. So fraction or a rational number will be terminating. It will be terminating only in the case if the denominator in the standard form, this is very important to keep this thing in your mind. The denominator value in the standard form has only prime factors, either 2 or 5. That's it. But the most important thing over here is the numbers should be written in the standard form. Means they cannot be further simplified. Only then we are allowed to check whether they are having factors either 2 or 5. If so, we can name them as they are the terminating. If they are not carrying these factors 2 or 5 for both, we simply say them they are non-terminating. Got it? Let's see a few examples. So this is 9/7. So can this fraction be further simplified? No. What does it mean? It means this is in the standard form. This fraction is written in the standard form because it cannot be further solved or simplified. Now start making the factors of your denominator value, which is 7. So once we start making the factors of 7, so we got only just one factor, which is 7. Now see whether we are getting 2 or 5. No. So we are not getting either 2 or 5 for both in these factors. So we simply named it as they are not terminating or non-terminating, right? Okay. Next question, 20/6. So first we have to see whether this fraction is already in the standard form or not. Can this be further simplified? Yes, it can be simplified. So simplify it. So we'll get 10/3, the times table of 2. Now again check, can this further be simplified? No. So it means this fraction is now in the standard form. Now start making the factors of this 3 denominator value. So the factors we are getting is 3. So we are not getting either 5 or 2. It means this is also non-terminating. For terminating, the factors you're getting must be either 2 or 5 or both, right? Okay, one more thing. Let's just suppose that this 20/6 already been written in the standard form, and start making the factors of 6. So in this case, we are getting 2 times 3 is 6, and 3 times 3 is 1. 3 times 1 is 3. So the factors we are getting is 2 and 3. So in this case, I am getting a factor 2, right? But this is, so we cannot say it as a terminating. Why? Because this number is not written in its standard form, right? So never make this mistake, right? Always first try to convert it into the standard form. Okay, moving on to the next question. 17/8. Can we still further be simplify this? No. So it means now we are allowed to make the factors of this 8. Start making the factors of 8. So the factors of 8 are 2 times 2 times 2. So we are getting one of the factors 2 or 5. So yes, we are getting, so we can simply name it as it is a terminating fraction. right? Terminating means if you keep on solving, you will get a remainder 0. Next, 19 over 45. Can this further be solved or simplified? No. So start making the factors of your denominator value, which is 45. So we are getting 335, right? So in this case we are getting 335. So we are getting 5, but also we are getting other two values, which are 3 and 3. So in this case this is non-terminating, right? For that you are only getting 2 or 5 for both. We will not be having any other value except 2 or 5. If you are getting other values besides 2 and 5, in that case the question or the fraction is non-terminating, right? It keeps on moving. Next is 6 over 20. Can this be solved further or simplified? Yes. So we got 3 over 10. Now can this further be solved? No. So start making the factors of 10. So the factors of 10s are 2 and 5. So since we are getting both 2 and 5 in our factors, which fulfills or completes the definition of making it as a terminating decimal, so yes, this fraction is our terminating decimal, right? So yes, here comes to an end of our today's lecture. I hope you have got the concepts. Stay blessed, be happy, keep smiling, and thank you once again guys for watching and learning here. Keep learning and stay safe out there. We'll catch up later, and good luck.
I need to kick the habit that my mind is breathing in.